Welcome to the talk about best practice in offline first and the learnings we gathered across the past few years. My name is Ola Gasidlo. I'm a lead developer at Styla and a CTO at Angefragt.js and organizer of various conferences, meetups, and way more. So today, I would love to tell you a little bit about the actual state of offline first, how our point of view has changed in the past few years, and how it's actually adapting to the real world. Before I start, I'd like to mention that in this talk I speak about a pandemic and death. There won't be any graphical display of those topics, but just to let you know in advance, and there will be a lot of GIFs, as usual. So if you'd rather leave because you do not feel comfortable with that, I fully understand, and I'm super happy to chat after the talk, plus give you like a short summary of the content. Okay, let's start. Internet turned 25 this year, so amazing times we all live in, right? In this time, our relationship with the internet, it changed a lot. We do different things with different devices than 25, 10, or even 5 years ago. And it's a part of our everyday life. We rely on our devices and the internet, but our needs changed. 3 years ago, when the offline first movement got like broader attention, I gave my first talks about offline first concept. That was 2013. What was our idea back then? Why did we need the offline first concept so badly? First thing was the rise of the mobile devices and the usage. There are countries where people do not even use desktop devices anymore at all. When you think about how cheap a phone in comparison to, for example, a laptop is, it totally makes sense, right? A mobile device is mostly enough for everything you consider the users actually need it for. Also, there still is the issue of no constant connectivity or poor network coverage. Here, offline first felt like a huge enhancement to our application and the new behavior. So, 2016, 3 years later, what do you think? Do we still need it? Tell me, by raising your hand, who of you is already building offline first applications? A few, awesome. Who of you thinks they kind of know how to build and how to follow the correct approach to offline first? Which is good, because still haven't figured that one out. Still trying, so you're probably totally right with it. And who of you thinks offline first concept as progressive enhancement? Okay, good to know. After seeing offline first in the wild, we've realized it's not just about a special use case or the rise of the mobile devices. It's about the whole approach. It's just so much more. As Jack Archibald once said, offline first means getting on screen without a network request. The more that it's there before the network, the more offline first it is. This means every web application should work without a connection after the very first visit and just use the network for getting and setting new data. Everything else is online first. So remember me asking you like way ahead 3 slides ago if progressive enhancement, offline first, you remember? Well, quite many of you said yes, totally. And what if I tell you that you're actually wrong? This might sound confusing, but why is the offline first concept progressive enhancement? Like, actually, it's not, because it's the other way around. Let's take a step back and see, why do we need applications? Normally, we use our applications for our everyday lives. So to make it easier or better, whatever you want, like checking in with family members and other loved ones abroad, or just texting your partner during the day. Using Slack, RC, etc. at work, especially in remote teams. This all comes down to communication. We also need application for like tracking your data, like did I not drink enough during the day? How much money did I spend that week? But also, how can I fix my bike or my washing machine? How did I translate that sentence, or even did I spell that right? Basically, that is all about information. Posting selfies from your last vacation, tweeting your thoughts, discussing, etc., checking in symptoms where you're sick, or even check the internet while your kids act out, doing that all the time. This is all about empowerment. And the most important thing there is, cat gifts, which is a basic life need, and I think we all can agree on that. So this one sums up to love. When we look at those points, communication, information, empowerment, love, we all can break it down to help and satisfy very basic human needs for safety, belonging, esteem, and self-actualization. Maslow defined all those points in his hierarchy of needs in 1943. So since when is helping to fulfill people a basic human need, progressive enhancement? But we love to sell it that way. So people jump on the progressive enhancement train and just redo the application like every 6 weeks in the new cool framework or whatever they need, without knowing what the real issue is. Kind of tired of those half-done rocket and ship-it applications, which are released out in the wild without any kind of documentation, pretty much nothing, because someone wanted to refactor the applications really quick in this new cool stuff. And yeah, temporary. We all know that, right? So we have all the super, super slow and buggy and messy applications just because of bad planning and messy architecture. Rethink. We do not need a new Uber or Twitter. Really, trust me. We tend to forget that these are jobs. It's about people, humans, not about frameworks, not about tag design patterns or discussions about semicolons. Don't build a town when you actually just need a house just because you can. Especially because normally you always end up with the gorilla banana problem. You wanted a banana, but what you got was a gorilla holding the banana and the entire jungle. Every time you use a whole infrastructure, like a framework, to solve one problem, you get all this implicit environment that carry around with them. It's all about keeping things simple but solid, basic but optimized. This is why I think putting offline first in the progressive enhancement slot is pure BS. Do you know what progressive enhancement part of your application is? The network. So you might ask yourself, why should I care? My apps are working, right? Are they? Ever check the application without a connection or with a bad one? How productive are you, for example, when just one server like GitHub is down, not to mention the office Wi-Fi? How easy is it to communicate with your friends on a concert, for example, when everyone is sending like live streams of the concert through their phone? And besides us, with a good connectivity situation, blessed people, there are others. So we're not just the wealthy Western web, as Bruce Lawson once defined. 43% of the population has access to an internet connection, and just a small amount of those to a fast and steady one. And data is expensive. As you can see here on this list from Ben Swartz's talk about performance metrics, Germans would have to work for less than 1 hour for 500 MB. People in India, about 17. So let's assume you have a 500 MB plan, right? So this would mean you can visit almost 7 websites per day, nothing else. You could watch one video, like one talk, in this month, and then done. Or you could make people really, really happy and write all the emails you're actually procrastinating on, without attachment, of course. So the application should provide the base and work offline per default. The network is the one to enhance the application with new outside data. No matter which technology stack we actually use, peer-to-peer network, that was the quick direct connection to the server, or USB stick, whatever works to transfer your data. It's not important how you transfer the data or application on your device. What is important that you have saved everything locally and enhance the sync through network. Not sure if this is true. Let's check out what is happening in the real world and how others solve the offline issues. Let's start with the router. So imagine a beautiful morning. You've decided to work remotely because we all do that on our vacation, right? And you're sitting in an internet cafe. So you'd love to check your emails. Cool. Connect your laptop to the router, open your email app, send the request to get your emails. Close the laptop, come back in the evening, and you're like, wait, what, evening? Wasn't just morning? Well, actually, there's no physical connection that the internet cafe is using, like a cable. They just have a router that saves a request and connects via Bluetooth to a bus. It syncs, and the request, and off it goes, literally. The bus arrives at a stop half of the route to the hotspot with a physical connection and syncs with another bus, also exchanged all the data, plus passengers and luggage. The buses sync via Bluetooth, previous requests and results. Both buses return, literally, and yeah, you get the emails, hopefully, if you were able to authorize. The tech behind the SNC net servers is a combination of NSC zone, CTN routing, and the darknet, not to be confused with the darknet, by the way. So what are learnings here, especially in focus on requests and assets? Check your requests. Do you actually need 20 requests, or would 2 actually just to be enough? Please serve uglified and minified files, because yes, it matters, the size matter. And do you really need that 5 MB background image for mobile? Beware of Li-Fi. Li-Fi is the state where your device checks your connectivity situation and assures you you're definitely online, pinky promise, but there's actually no data passed through. We could go also with like checking the bandwidth after the very first ping, right? Yes, that could be a thing. And we could develop something similar, like media queries and device sizes just for bandwidth. That would be great, so we could load assets per detected true bandwidth, right? Yes, mind-blowing, might be a great idea, but the bandwidth can differ per request, even per package, especially when you're moving, for example, on a train. We would need to ping not just per every request, but constantly. And we can't rely on requests to come back. Please add a timeout to kill your request, or make the app work fully independent of requesting data. This is why we also need to separate updating cycles of assets and data. The update of assets is less important than actually syncing the data. Save a basic set of UI locally, and just to go easy on the start, so very basic. And enhance that, for example, with web fonts, images, whatever floats your boat. Offline should be the default state, and we need to make the bandwidth assumption per device we detect. Take responsibilities of the caches and keep them clean. What could be better to manage caches if not service worker? And nope, no introduction to service worker. I think we have enough people to do that today. Just one thing. If you want to use app cache for quite a bit, because browsers are dropping the support hard, but also for migration from app cache to service worker, please check out the JCache. Images, hard already, but hard to deal with even more within the offline first context. Saving images in the in-browser storage, good way to go, but still very painful because of storage limitations and very different story limit implementations. Porting decorative images, like logos, for example, to SVG and CSS is a great way to go to cut off a little bit of the overhead. Encoding assets in base64 and storing the string in the browser storage of your choice could be also a way to go. For example, saving fonts like that and loading them straight from the storage improves your performance enormously. Then it's even possible for images like logo, but please do not do this for all of your images, because I've already seen it. Don't build the town when you just need a house, just because you can, remember? The strings are huge, as we already know, and the in-browser storage are limited. Also, decoding base64 on the fly is a very, very heavy task. It slows down your site, especially in combination with DOM manipulating frameworks like React, for example, and you might run into race conditions there also. So, first example, now the second one. This one is a little bit heavier, so know you're in advance. The pandemic. 2014 and 2015, the Ebola pandemic in parts of West Africa was a really scary issue. I was involved in a project by the NGO eHealth Africa to build 2 applications to help stop the pandemic. The first application was to solve an issue with providing information, because information is the key to spread the pandemic and kill. The process was, the population was informed about a specific number that could call to ask questions about Ebola symptoms, to report someone sick or even dead. The call center tracked the calls with the application we've built and collected all the data they needed and sent out a team if needed. They added information through the application like name, location, additional information also, added the phone number of the caller, so when they had questions, I had to follow up, they still could do it. Data analysis and filtering was really easy thanks to that application. We fought with issues like unexpected and constant power loss. The generators jumped back in after quite some time, but we could not afford to lose data. Just one case could have caused another outbreak and killed many people. So one of our learnings here, especially about data, was decouple server and client to serve the needs of eventual contingency. Built in a task and message system that can act independently from the connectivity situation. For example, for data, CouchDB, especially in combination with Pouch, has proved their usability in the real world really well. CouchDB, a NoSQL database that replicates, is pretty much exactly what we want. CouchDB comes with a suite of features that we need, such as on-the-fly document transformation, real-time change notification. We need those for the message and task system, but also for decoupled architecture. CouchDB is an open-source JavaScript library inspired by Couch, so the API is pretty much the same, but the implementations are different. And it's designed to run well within the browser and store all your data locally. It syncs with CouchDB thanks to the CouchDB replication protocol. So when your application is back online, they ping each other, and done. With CouchDB, we actually have documents which are stored locally, so we don't flush the caches by accident. One of the biggest issues with syncing data are merge conflicts. Because CouchDB and Couch speak the same protocol and sync automatically when we're back online, we do not need to take care of that. Second application we developed was to actually track patient data in the field. After examining the infected patients, which had to stay in quarantine for 21 days. The team added the data to a general database through the application, plus got rep results from several different entry points and very different file types. The data was imported and saved to a global database. It was synced then all across all of the devices we had. This sounds pretty messy, but we cleaned it up. So another learning was about schemas. We added an organization system, an interface, to map the data in one defined schema. The schema was flexible enough to be extended if needed, thanks to a NoSQL database behind it. Data was imported automatically when it arrived, mostly per mail, and we added data on the fly. Constant automatic testing and high test coverage for the imported interface was a must. The schema and testing helped us a lot here to prevent merge conflicts from the get-go. CouchDB and PouchDB helped us to take care of sync, merge, and flexibility. Big bonus also, the schema also helped us with making a filter and analyze the data, so visualizing it was really easy. We helped to curtail the pandemic because of clean data structure and constant testing for the application. If anyone else tells you now that you don't need this stuff or you don't have time for that, now you know what to reply, right? Okay, so almost lunch. People are already leaving, sorry. Well, the next use case, and that's the last one, is, I guess, well picked then, sorry in advance. It's about the pizza. So, we all love to order food, right? Did you ever check the local storage while ordering? Like if they saved the items in the cart locally? A friend of mine did that once, and he went a bit further out of curiosity. So he was wondering if they're actually validating the checkout on the server. He manipulated the checkout and subtracted just 1 cent, sent it out, and waited. The pizza came, and nope, no server-side validation. Cheap food. So, also learnings on security. In contrast to the limited possibilities of our use case before, this company could have validated the data on the server, right? But this sometimes is not possible, especially when everything needs to work without a request. Security is a very new topic to offline first, and not many tools are provided yet. And I would like to ask you, after this talk, and later in the PWA discussion also, let's talk about it. Let's discuss it. I'm really curious about hearing your thoughts about it. Although many of us seem to hate core sometimes, it provides already a great set of features and rules to make the applications more safe. But it does not solve the issues with the in-browser storage manipulation. One way to go would be to encrypt your data when you use PouchDB. You can add CryptoPouch, which encrypts the pouch documents. Well, big downside of that is the documents get encrypted, but not the IDs. So when you reverse engineer, there are still security issues. But at least you can't manipulate the data in the console anymore. When you want to encrypt the data, you just might want to log in. Surprise. Which does not work without a request, right? So there's a way to use tokens in the client. JSON Web Tokens is a great open industry standard method for representing claims securely between two parties, which is exactly what we want. It makes decoupled and secure sync and communication possible. Okay, short bonus level, because this is pretty much the most creative use case I've ever seen and ever heard about how someone solved the offline issue, the rally. Anyone of you ever heard about the Mongo already before? Could you raise your hand? Okay, just a very few. It's an unconventional rally where people start from either London or Czech Republic. They drive down to Mongolia. The main intention of the rally was a donate your car program when you actually make it to Mongolia, because the cars had to be really old. So they could be donated without importing duties. 2009, a team from Spain took part in the rally. Nothing special here at first glance. Well, the issue of the rally was they had to cross a lot of countries with different reception, different payment models for data. They needed a way to communicate with the loved ones and just to say, yeah, we're cool, or could you send some money and bail me out of jail, please? Sorry. So they built a system that could encode an ASCII message in 8-bit binary code, ran that through 8 phones that actually called just one number. This is how it looked like. To save money, they didn't establish like a full connection. Short ring was a 0, long ring was a 1, and at the other end, check the numbers, which were set for the order of the bits. Decoded the ASCII, the binary back in ASCII, send out the message. Mind-blowing, right? Humans. Learnings, the very last learning here. Rethink how to use technology by thinking about the issue, not about the tools. Unidirectional communication, it's so basic. They fixed it already in the beginning by thinking about the real issue and not about the solution first. So, time is up. I hope you had a really great time. And if you have any questions, let me know. And remember, it's not about frameworks or design patterns, tools, or semicolons. It's all about humans. Thank you.